Hello, in this video I'm going to solve the following problem for you. Evaluate the following integral. Integral of x times e to the x times cosine x dx. That would be a good idea if you pause the video at this point and try to solve the problem yourself first. If you do the calculations correctly, this is the answer that you will get. 1/2 x times e to the x times sine x plus cosine x minus 1/2 times e to the x times sine x plus a constant c. Okay, now let us see how we can solve this problem. My strategy to tackle the problem is to use integration by parts several times, as I am going to explain now. The formula for integration by parts, of course, is this one, as you already know. Now I want to give the role of u to x, and what is left for me, I want to give it the name dv. And then you see on the right hand side, I need u, which I have it. I also need v, so I have to find it. And I also need to find du. Okay, so that's the standard trick. U is x. This means that du becomes dx. And now here, dv is equal to e to the x cosine x dx. In order to find v, I have to integrate this function that we see here. Okay, but that is also problematic. So I spent a little bit of time to be able to calculate this integral. But of course, this is a very standard integral in the topic of integration by parts. But to refresh your memory, I will go and solve this one for you as well. So let us give it a name. I give it a name j, and now I want to calculate j. Again, the trick that I want to use is actually integration by parts. So let me rewrite my j here. And now I want to give the role of u to e to the x now, and give the role of dv to cosine x dx. And still I want to use the same rule. Okay, so u is e to the x. What is du? Du is simply e to the x dx. And of course, dv is cosine x dx, and v is simply a primitive function for cosine, which we know is sine x. Then I use this formula for integral j, and then I would write j is equal to u v. Here u is this and v is this, so when you multiply them you get this term, and then I have minus integral of v du. So this is my v, this is my u, but when I multiply them I put e to the x first, just to keep the order and be organized. So we will get this. But of course, as you see that I have more or less the same problem here. This is more or less very similar to my original integral j, but instead of cosine now, I have sine. So the idea is to use the same trick once more, okay? So I call this k. And now my goal is to calculate k. Okay, so again, k is this integral. I want to use integration by parts again by giving the role of u to e to the x again, but I want to give the role of dv to sine x dx. So u is e to the x. This means that du is e to the x dx, and my dv here is sine x dx. So v is a primitive function for sine x, which of course is minus cosine x. And again, I use this formula here again. So u times v. So integral k is equal to minus e to the x cosine x, but minus integral v du. When I have v, it has a minus sign, which will cancel this minus sign. So I will have plus integral e to the x cosine x dx. But as you recognize what is happening, this integral is again j. Yes, so instead of that one, I can write j. And what do I get? I get k is equal to this plus j. Yes. Okay, so this might be a little bit useless because you think that we are returning back, but if you have studied this integral before, you know what the trick is. Okay, so now my goal is to find, do you remember, my goal was to find integral j. Okay, so I changed j. In order to calculate j, I faced a new integral k, and when I wanted to calculate k, I faced the same integral j. Okay, but hopefully you know that this is not a cyclic argument because of the minus sign that appears in a formula of the integration by parts. So let us see what do I mean. Okay, so what I have done here, because k is equal to this expression plus j, okay, and I have gone back here, you see, j is equal to e to the power of x sine x, which I have written here, and then I have this minus sign, which is this minus sign, but instead of k, I have put this expression here. So this is just simply your k. Okay, and then of course now I open the pair of brackets. So the first term becomes positive, so the next term becomes negative. Now I move this j to the other side. Because this is minus j, when I move it to the left side, it becomes positive j, so it becomes 2j equals to this one. But I am looking for j, so I divide everything by 2, and this is the answer that I get. Okay, now we know j. J is actually the v that I needed. So now I go back to calculate my original integral. So let me give it a name, I. So now I want to calculate I. In order to calculate I, you see I need to multiply u by v. This is u in this problem, v is equal to j, and j is this one. So when I multiply u by j, 1x will go here and 1x will go there. So I will have two terms, 1/2 x e to the x sine x plus 1/2 x e to the x cosine x. But I have a minus sign, integral v times du. So I have to take, this is my v, and multiply it by du, which is dx. So a dx will go here, a dx will go there. So I decompose it into two integrals. I pull factors of 1/2 out. And because of this minus sign, both the factors of halves become actually minus a half. So this becomes minus 1/2 integral e to the x sine x dx minus integral, so minus 1/2 integral e to the x cosine x dx. Okay, but what is the name of this integral? This name is just simply j. And if you look here, this integral that you need here is exactly the integral k that we calculated here. So the name of this integral is again k. But of course, we didn't calculate k completely. We calculated that k is equal to this plus j. But now I have j here, so I will add this one to this expression, and then I have my k. And of course, you see this is minus e to the x cosine x. This is positive 1/2 e to the x cosine x. So if I combine this one with this one, I will have that k is equal to this expression. So now, as you see, everything is ready. So I is equal to this expression minus 1/2 k minus 1/2 j. Okay, so I will actually move these information that I need to the next page, and then we continue. Okay, so now I moved the information we need from the previous page here. This is the result that we got at the very end, and we also calculated what k is and what j is. So my What I'm going to do now, I want to just replace k with this expression and replace j with this expression. So let us just do that. So I is equal to, I just copy and paste this part, okay? And then I take the k, which is this one, and I multiply it by minus a half. So it becomes minus 1/4, and then this becomes plus 1/4, yes? So that is what we get. And then I will take j and multiply it by minus a half. So both of them now become minus 1/4. Okay? But then it is extremely simple to see that this term and that term are totally cancelled. But these two terms are similar. So I have minus 1/4 here, minus 1/4 there. It becomes minus a half. Yes? So if I want to write I, of course, I can make it more beautiful if I take this factor out. So that would be my first term, and my second term, as I told you, becomes minus a half e to the x sine x. And of course, now it is a good point, it's a good place to introduce the constant of integration. So actually, that is the solution to this problem. Okay, I hope that this video was useful for you. Until the next video, be safe and goodbye. Thank you.